This is Dr. N. Amudhapriya, Associate Professor Triply from Rohini College of Engineering and Technology, Palkulam. We are here to discuss about the transmission and distribution course for the regulation 2021, and this lecture 2.3 covers the power circle diagram. This is a single line representation of the power system, which comprises of generator on the sending end, and after which we have a bus bar, and then the transmission line, which comprises of the resistance and line inductance parameters, and next at the receiving end we may have a bus bar again, and which is then supplied to the load. Here we can represent the transmission line with the help of the ABCD parameters. So now it's a thing which has to be calculated regarding the electricity flow from the generating side to consumer side is nothing but the calculation of active and reactive power. So since circles are convenient to draw, the circle diagrams are being used for visualizing the impact over the single phase transmission line. Now let us have some terms and then start drawing. And while drawing, take VR as a reference one, and let it is lagging behind VR as phi R value, from which we have drawn the IR value in phase with I, and then at 90 degrees we can draw IX value. Connecting both of them, we will get VS value, and the angle between VS and VR is del. While calculating the total receiving end power, we have got this equation. It is minus A by V, VR square angle B minus delta, VS VR by V angle B minus del. So A by B, VR square angle B minus alpha, VS VR by V angle beta minus alpha. Actually, the first term is a constant phasor of receiving end power, and the second term is a phasor of fixed magnitude but variable angle of receiving end power. And on adding up both these things, we will get the total receiving end power. This is the thing. So we should have this first term, minus A by B VR square angle B minus alpha. Let us consider the horizontal term and the vertical term, that is the cos value and the sine value. This is the power circle diagram. The x-axis is megawatts, that's the real power, and the y-axis consists of the reactive power. So let us draw the value of I, right, from at an angle of B minus alpha. So this is what is the first one. The center is located by drawing the OC value, which is nothing but minus A by B VR square, the voltage value at an angle of B minus alpha. And next is from this, from the center C, this is C, consider this as a center. The receiving end circle is drawn with the radius. What is the radius? VS VR by B is the radius. With the C as center and VS VR by B as radius, you draw a circle. And after this, you have to spot the operating point M. For that, what you have to do is, you have to draw the value, you have to take the operating point M on the circle, which is located by means of the value PR, which is the real power. From the real power value, we have to draw OP. And from there you can you can connect the value for value of O and M. You can connect it. We get the SR value. If VR is constant and VS varies, the center of the receiving end circle remains fixed as center. If VS is constant and VR varies, the center of the receiving end circle moves along the line OC. This is what is the case. Thank you.